Frame analysis. Video 11. Steel design according to second order theory. We have now designed the steel frame according to a first order analysis and reached an acceptable solution. We will now verify this with regard to second order theory. It is then important to take into account initial bow imperfection if we disable for first order theory. We will then return to the program part input geometry, choose the tool initial bow imperfection, and define this for the entire frame. For a member only affected by axial load, no first order moment will develop, and thereby also no second order moment, since the check with respect to flexural backing lies in the growth of the second order moment. It is of course important that there is a second order moment in all members. The requirement is that at least a moment corresponding to initial bow imperfection is present in all members. Therefore, if not initial bow imperfection is activated, no design according to second order theory will be allowed by the program. To perform an analysis according to second order theory, we activate this option before the analysis and select Calculate. We then move to Program Part Design. The important difference with the previous calculation according to first order theory is found under the option Support Conditions. In the previous calculation, apart from the support conditions necessary to calculate the backing length out of the frame plane, also backing length in the frame plane had to be defined. As the flexural backing check in the frame plane now is made with regard to the growth of the second order moments, this is no longer necessary, which is one main advantage by designing in accordance with second order theory. Additional input is as shown earlier for first order theory. We perform a calculation, and this time a message is displayed that the flexural backing check is made with regard to second order section forces. We now see that the column number 5 is colored red, and the utilization table shows that the member is overutilized by about 18%. Also the beam number 9 is now slightly overutilized. A check for number 5 shows that it's the flexural backing in the stiff direction. A check now made with second order moments that exceeds the capacity, and also the lateral torsional backing check present a problem. A preliminary design directly in the code check window indicates that HA 260 is not enough. It requires a HA 280, so we create one and tie it to member 5. Then we make a new analysis and a new design. In the code check window, we now see that all checks for the current column is okay. And if we finally examine the utilization table, we see that the beam number 9 is near the limit and perhaps should require some actions to be taken in the same way as previously shown. In summary, we see that the frame structure that was okay according to first order theory needed to be strengthened somewhat due to second order theory. The reason for this is that our assumption at first order theory that the backing length of the column is the same as the actual length was incorrect, and a slightly larger backing length should have been selected. This is also the big advantage of second order theory. The sometimes complicated estimation of the correct backing length in the frame plane need not be made when the flexural backing check is made with second order section forces.